Hey folks, Miss Gosling here. In this video, you're going to learn about work. By the end of the video, you'll be able to define work and solve problems involving work. So let's go ahead and get started. So first of all, let's start by defining what work is and what it isn't. And I'm actually going to cross off one of these equations because it is in fact a little beyond the scope of this course. So what is work? Work is not homework or your job or anything like that. When we talk about work in physics, what we're talking about is what the effect of forces are on an object. So we define work, which we represent using the letter W, and which we measure in joules. Work is equal to the work done on an object is equal to the force acting on an object parallel to any displacement of the object. So what this means is if I bend down and pick up a box, walk over 10 meters, and then lift the box up 5 meters and put it on a table, I am only doing work when I lift the box. When I pick the box up and push it across the ground, or if I pick it up 5 meters and carry it, I'm not going to do any work because I don't have to apply a force to do that. So once I've lifted it up 5 meters, I'm no longer going to need to use any force to move it because it'll be moving at a constant velocity. So no force is needed to move it. So key point here, guys, is that work is only done if our force is in the same direction as our displacement. If our force is up and our displacement is to the right or to the left, then no work is done. So let's go ahead and look at an example problem. You lift a 5 kilogram box up 100 meters. How much work did you do? So here is my box, which has a mass of 5 kilograms, and I'm going to lift it up 100 meters. And to lift it up, the minimum force that I need to apply must be equal to and in the opposite direction of the force of gravity, or my mass times little g. So with that information, I'm now ready to list out my givens. So I know that the mass of my box is 5 kilograms. I know that little g is 9.8 meters per second squared, and I know that the distance my box travels is 100 meters. And my unknown in this situation is the work that I'm doing on the box, which we're going to again represent by that letter W. So I know that my equation for work is equal to force times displacement. And in this case, my force is the force of gravity, or equal and opposite to the force of gravity. So that means my work is equal to my mass times little g times my displacement. Now that I have that, I am ready to sub and solve. So I know that W is equal to mgd, thus my work is equal to 5 times 9.8 times 100. Thus, the work required to lift that box up is 4,900 joules. So there you have it, guys. I have now calculated the work required to lift a box up. And in general, when we are lifting something up, this equation here, work equals mgd, will hold. So work is equal to the force of gravity times the height that I lift my box up. So let's look at another example. You use a rope to pull your sister on a sled. So here's your sister on a sled. You apply a force of 50 newtons, causing her to move 10 meters. How much work did you do? So let's go ahead and start by listing out our givens. So I know that the force acting on my sister is that 50 newtons that I am applying. and that she is moving over a displacement of 10 meters. I also know that I'm trying to find my work. So I can, under the unknown section of my guess method, write work equals something. Now I know that the equation for work is given by work is equal to force times displacement. Thus, I am now ready to, before I continue finishing this problem, start my sub and solve stage. So to sub and solve, I'm going to go ahead and put in my numbers from my givens. So I know that work, which is my unknown, is equal to my force of 50 newtons times my displacement of 10 meters. Thus, the work required to move my sister is 500 joules. And there you have it, guys. Here is yet another example of a work problem. So, takeaways. First of all, work is force times distance, and we can use the equation work equals force times distance to solve problems. Another key takeaway that I want to mention, we only care about distance that is in the same direction, that is parallel to forces that are applied. So with that, you now know how to solve work problems. It is your turn to give it a try. Best of luck and happy solving.